Hi everyone. Uh, Today I'm going to ask Amir to help me find a derivative of another function. And the objective of this video is to use implicit derivative and find the derivative of a function using this concept. So Amir, the problem that you're going to solve is we have a function here, x squared plus y squared equal e to the xy, and you're going to find the first derivative of this function at a specific point. The point is x equals 0, y equal 1.
Sure. Thanks, Hussein, for the problem. Okay. Let me just first adopt the notation of, instead of using dy over dx, I'm gonna consider, this notation throughout
Okay,
the
y
problem.
prime.
It's
Okay,
shorter.
no problem.
Okay. I start by taking derivatives from both sides of the function. So
Before you get into solving this, can you
yeah,
explain why we use implicit derivative here instead of like regular derivative,
yeah,
explicit derivative?
because for example here, if I want to obtain y in terms of x, it is difficult. We cannot solve y in terms of x. It is not explicit. That's why we use the term implicit. It means that you still have, x, for example, next to y here,
Okay.
and you cannot, move it to the right side. So
Okay.
yeah, that's the reason
So
that
using
we,
this concept, you don't need to isolate y on one side
yes,
and
yeah,
then, all the x's on the other side.
yes, we just take derivative of both sides,
Okay,
and then we
sounds good.
obtain the derivative.
Okay.
As we proceed, we can do that. It can be explicit after taking derivatives. So I'm gonna take derivatives in terms of x,
Okay.
as I explained here.
So the
Uh,
prime that you add on both sides means that you're taking the first derivative.
yes, correct.
Okay.
So it's going to be 2x plus, okay, this is like we use the chain rule here
Okay.
because y is itself in terms of x. So it's going to be 2y
Right.
prime.
Right.
Yeah, I'm using the short form.
Right.
We in previous videos we covered chain rule, so
Right.
here we just use the short form.
Yeah, the viewer, if you want to review, refresh your mind about the chain rule, watch the our previous video. We will put the link here for you. You can watch it later.
Yes, and then for the right side, okay, we have, this, when we have e to the power of u, where u is in terms of x, and then the derivative of that in terms of x is u prime e to the power of u.
Right.
So using
U
this,
prime means derivative of u with respect to x.
that's correct. And then for the right side, it's going to be, so in our case, this is u. So it's going to be like the derivative of the first one, which is x, which is 1 times y, plus the derivative of the second one, which is y prime times to the first one. So it's going to be x times y prime, e to the power of x, y.
Okay. Again, as a reminder for the viewer, what Amir did in the parentheses before e to the xy is product rule that we have a video about it. We will put the link here.
Yeah. So, okay, now you can see after taking the derivatives of both sides, we can obtain y prime in terms of other terms in
Right.
this relation. So let me just,
Basically, you're finding explicit relationship for
yes,
y
yeah,
prime. Y
yeah.
prime.
So after taking the first derivative, so let me just write it down again. This is going to be y e x y. So it is,
Yeah. distributive property.
Yeah, x, e, x, y, y prime.
Right.
Okay, here we have y prime here and y prime here. So I can obtain actually y prime in terms of other terms.
Right.
Therefore, let me move this one to the right. So I get 2x, and I move this one to the left. 2x minus y e x y equals x x y y prime minus 2y y prime. This then can be rearranged like xy equals x e to the power of xy minus 2y y prime.
Okay, you're
Am I right?
factoring y prime. Yes.
Okay, yes. And then I obtain y prime as 2x minus y e x y, and then in the denominator I have x e x y minus 2y. So
You divided both sides by the multiplier of y prime.
yes. So this is the answer, but we want to have the derivative at this point. So for x of 0 and y of 1. So I replace actually 0 and 1. I get 2 times 0 minus 1 e to the power of 0, because x is 0.
Right.
And then here is 0 times e to the power of 0 minus 2 times y. So if you just simplify, it's going, and we know that e to the power of 0 is 1.
Right.
So it's going to be minus 1 divided by minus 2, correct?
Right.
So the derivative at 0 and 1 is equal to 1 over 2, or 1/2.
Right.
So yeah, that's the final answer for this problem.
I wanted to add also, you don't need to find explicit equation for y prime. You know, you can just plug in all the numbers you want and then, you know, find the y prime. So that is also another method to solve this.
Yes, yeah, immediately after finding this one.
Exactly.
Yeah, that's a good point. But if you want to have the explicit relation, that's the one that we have actually here. Yeah.
So Amir, can you also maybe use Desmos to just draw this function and maybe show what you obtain here? Maybe a you know, a visual representation would help the viewer.
Sure. Yeah. X squared plus y squared equals e to the power of x y. So yeah,
that's the function, right?
Yeah. Let me just have a screenshot here. And I go back to GoodNotes. Okay. Oops. Okay, I guess it is just there. Let me just show you here at point 0 and 1, which is here. We have, you know,
we want to find the derivative at that point.
And derivative means that the tangent on that point over the line. And if I just, you know, look at the tangent of this angle, which is alpha, tangent of alpha is 1/2.
Which is the y prime that you obtain.
Yes, that's a y
Equal
prime.
to the y prime.
So I guess
Okay.
that's the illustration of the problem.
All right. All right. Thank you, Amir. I appreciate it. For the viewers, this is all for today. I hope this is helpful. And if you learned something, please consider subscribing to our channel and also hit the notification bell for future videos. And thanks again, Amir, for helping us,
Sure.
understand this problem. And till next video, bye, everyone.
Okay, bye. Thank you.